See, now the topic is types of colloidal dispersion. Now the topic is types of colloidal dispersion. Three types of colloidal dispersion is there: lyophilic, lyophobic, and association colloidal dispersion. See, these types of colloidal dispersion that is based on the strong bonding between dispersed phase and dispersion medium. The extent of molecular interaction between the dispersed phase and dispersion medium. See, lyophilic colloid. See, take one beaker. Within that beaker, you can add water. Then you can add the hydrophilic colloid like gelatin, acacia, or tragacanth. Then spontaneously, there is a formation of colloidal sized particles, acacia or gelatin particles within this dispersion. This is a acacia particle, colloidal particle surrounded with that is surrounded with solvent film. If we people have heated or if we people have heated from the downside, then the solvent is get evaporated. The solvent is get evaporated. Then the particles, two acacia particles, are get precipitated by forming the weak bonds. If again, if we people have added the water to this system, the bonds will break. The bonds will break between these particles. Again, this system can be converted into the first one. Hence, we can call it a lyophilic colloids. We can call it a reversible colloidal system, because this first one can be converted into second one, again second one can be converted into first one. Hence it is bidirectional. Next, lyophobic colloid. See, lyo nothing but solvent, phobic nothing but heating. If the instead of lyo we can add hydrophobic nothing but water heating colloids. Here hydrophilic colloid nothing but water, philic nothing but loving. If it is hydro instead of lyo, then water loving colloid. See, this is a beaker. Within this beaker, we have added the inorganic metals. Inorganic metals that cannot form the colloidal dispersion spontaneously. So some special techniques are needed. Because of the technique, we can reduce the particle size and we will get this kind of system. Now, this is one metal, this is another metal. See, this metal is get stabilized because of repulsion between the two negative charges. Because of the repulsion, this lyophobic colloid is get stabilized. If we people have heated from the downside, then remove the water, then what will happen is once the water is removed, there is a strong bond between the two particles, two inorganic particles. There is a strong bond. Even though if you people have added water here, the bonds may not be get broken. The bonds may not be get broken. And again, that cannot be converted into the first one. Hence, we can call it a reversible phenomena. Hence, we can call it a irreversible phenomena in case of lyophobic colloid, reversible phenomena in case of lyophilic colloidal system. See here, lyophilic colloid. See, preparation is spontaneously. This is will form spontaneously. This may not form spontaneously. Some of the special techniques should be needed. Next one is stability towards the electrolyte. See, this system that contains solvent film, because of the solvent film, lyophilic colloids are more stable. If you people have added electrolytes, that electrolyte will remove the solvent film, that can remove the solvent film. After removing the solvent film, then precipitation of lyophilic colloid will be there. But in case of lyophobic colloid, that is negative charged. If we people have added a positive charged electrolyte, that easily precipitate the lyophobic colloid. Next one is this is reversible. Lyophilic, lyophilic colloid is reversible. Lyophobic is irreversible. We have discussed now only. Next, see that the viscosity of this lyophilic colloid is greater than the dispersion medium, nothing but greater than the solvent. See, the viscosity of lyophobic colloid is as that of dispersion medium only. Next one is this will act as a protective colloid. Lyophilic colloid act as a protective colloid because of presence of solvent film. This may not be act as a protective colloid because no solvent film will be there. This is thermodynamically stable, means stability is due to the solvent film only. This is thermodynamically unstable. Nothing but lyophobic colloid is thermodynamically unstable because no solvent film. Example of lyophilic colloid is gelatin, acacia, and other things. Inorganic metals that will comes under lyophobic colloid. See, next one is association colloid. See, slowly you can add the surfactant monomer, then what will happen? Slowly, the increasing the concentration of surfactant that may form the spherical micelles. See, this concentration we can call as a critical micellar concentration. The concentration at which there is a formation of spherical micelles we can call as a critical micellar concentration. See here, these monomers, this monomers concentration we cannot call as a critical micellar concentration. See, see, furthermore, if you people increase the concentration greater than critical micellar concentration, then laminar micelles we people will get. Laminar micelles, there is formation of laminar micelles. See, the concentration of this one we can call as a critical micellar concentration. Craft point nothing but the temperature at which there is a formation of micelles. We can call as a craft point. See, 1, 2, 3, like this, how many monomers to be needed? Minimum how many monomers to be needed means at least 50 monomers or greater than 50 monomers are required for the formation of spherical micelles. Hence, we can call as a aggregation number of micelle. Aggregation number of micelle is minimum 50 or greater than 50 monomers are required to form spherical micelle. So this is a micelle. Outside is polar, inside is non-polar in nature. We can solubilize the non-polar drug within this non-polar zone and we can deliver the drug. Next one is formulation factor. If we are using non-ionic surfactant, we can use internal or external use. If you people are using cationic or anionic surfactant, then only we need to use in the external because internally it will causes toxicity. Next, at low concentration. See, at low concentration, there is no formation of micelles. Here also no formation of micelle. This concentration is formation of micelle will be there. And see the drug solubility. When there is a formation of micelles, the drug will go into the hydrophobic region and the drug solubility also get increased and the drug absorption also get improved. At high concentration, due to the formation of laminar micelles, the drug absorption is get reduced. High concentration of surfactant that may cause toxicity. Hence, this is about the different types of colloidal dispersion.